Now, we all know that some 66 million years ago, a 6-mile wide space rock hit the Yucatan region, wiping dinosaurs off the face of the Earth. But would they have survived without it? Well, new breaking ground research suggests otherwise. Scientists at the Institute of Evolutionary Science in Montpellier have studied 1,600 fossils from 247 dinosaur species that lived during the late Cretaceous period, and they found that some dinosaurs had already started to go extinct before the impact occurred. Well, let's cross over to the co-author of this report, Fabien Condanim. Hello and welcome.
Hello, Julia. Thank you for having me.
So tell us more about how you conducted your study and what it is you discovered.
Well, we have studied the final periods of dinosaur evolution, and we wanted to test the hypothesis that a sudden extinction due to the meteorite impact caused their final extinction 66 million years ago. And we wanted to investigate whether there was like a gradual decline also. And for that, we analyzed the fossil record for 6 dinosaurs families that are well representative of the late Cretaceous. And we found about 250 species for which we compiled all the fossil material that can be attributed for each species. And this provided the raw data to estimate the ages of species origin and species extinction, which then allows us to estimate the accumulation of the number of species through time. And we found that the number of dinosaur species was more elevated 76 million years ago than 66 million years ago. So we found some evidence for 10 million years decline, which is likely due to the increase of extinction starting about 76 million years ago.
So what actually caused dinosaurs to start going extinct then?
To find the likely reasons explaining this decline, we modeled the rates of species diversification and extinction, and their correlation to 10 selected variables such as temperature and sea level, for instance. And we found that the increase of extinction in the last 10 million years can be probably attributed to a continuous global cooling and also to a drop in the number of herbivore species. And it is important to remind that the Cretaceous period is a very warm period, and that this cooling is important so that we observed a 7 to 10 degrees decrease of temperature globally. And for dinosaurs, such a decline represents an environmental deterioration. These animals are mesothermic, so they rely in part on the external temperature of their environment, and this cooling may have slowed down all their activity and biological activities. So the second reason is the drop of herbivores, which makes sense ecologically speaking, since herbivores are often considered as key species in any ecosystems, even today, such as Africa savanna, for instance. And the removal of herbivores in the Cretaceous have probably made all ecosystems very unstable and then prone to extinctions in cascades, so that all the carnivores, for instance, which depend on herbivores, could have declined after the extinction of the herbivores.
Well, Fabien Condanim, thank you very much for speaking to us here on Tech 24. It was truly a pleasure. Thank you.
Thank you, Julia.
Let's now welcome Peter O'Brien, our tech editor. Hello, Peter.
Hello, Julia.
Now, we've seen with Fabien, of course, that science is all about revisiting past beliefs, but also challenging all of the variables almost constantly. And it's true, of course, for dinosaurs, but it's also true for our own species. In fact, Charles Darwin, we all know him, of course, because of Darwinism, may not have had all of the answers.
Yeah, well, let's start with giving some credit where credit's due. A lot of his main ideas, so the fact that life is all related, that a species change is the result of natural selection, and that new forms replace those that came before, they all still hold true today. And besides, he was a humble man. He never actually claimed to have all of the answers. He actually wrote in Origin of the Species, "In the distant future, I see open fields for far more important researchers." Well, one of those fields has been the study of human fossils, and there weren't many at all when he was around, but now we have access to hundreds of them dating back 7 million years. That's dozens of species. Some of them are our ancestors, some distant cousins. Now, the main thing, of course, to remember is that this idea of a missing link, the kind of evolution that you see depicted on t-shirts or stickers, cartoons, this is outdated and actually a misinterpretation of Darwin himself. He never claimed that we were descended in a linear manner from another existing species of ape. We just share common ancestors. The amazing thing, though, is with all of these experiments in human life that there have been over the course of evolution, well, all of them have ended in mass extinction of those species, apart from one, and that's us. Well, so far at least.
All right, now if evolution isn't linear, then how do scientists actually see it?
Yeah, so they map it out using models called a tree of life. It looks a bit like this, and to give it its scientific name, it's the phylogenetic tree. So you can see over here on the top left, that's us Homo sapiens, and on the right here, you can see the Pan genus. So that includes the bonobo and the chimpanzee. And we're not directly descended from them, as you can see, even though we're their closest relatives. We actually come from this same ancestor. Now, scientists have been trying to track these kind of trees all the way back to what's known as the Luca, which is the last universal common ancestor. That's the organism where all life on Earth currently is descended.
Now, how do they actually go back in time like this, and so far back too?
Yeah, so there's no fossil evidence for the Luca, the last universal common ancestor. It's just too old. But the puzzle, the genetic puzzle, can be pieced together through what we know from living organisms today. You can see a few of them here. You can recognize some animals, fungi. All of them come back to this Luca. What's more difficult to take into account, though, is horizontal gene transfer. And that's when genetic material is passed from organism to organism without reproduction. So one example is the spread of antibiotic resistance in bacteria. That's an example of horizontal gene transfer. In this sense, scientists are starting to see the tree of life as more of a network than a tree, at least with the smallest organisms.